All right, 5.1, perpendiculars and bisectors. All right, tell whether the information in the diagram allows you to conclude that C is on the perpendicular bisector of AB, and then explain why or why not. So number 8, I have a triangle. So they give us this information and they want us to say if C is on the perpendicular bisector of AB. So what do we think?
No.
Why?
Because a bisector splits things in half and 8 is not equal to 7.
Yep. So no, because CA is not equal to CB.
Is that
So
P?
there?
Mm-hmm.
Yeah. C is not on the perpendicular bisector of AB. Tell whether the information in the diagram allows you to conclude that P is on the bisector of angle A. All right, so what about this one? Does this one show that P is on the bisector of angle A?
I think yes.
But there's no line, right?
Well, there doesn't necessarily have to be because you can have like an imaginary line there. But the answer is no, because the diagram does not show that both of the segments with equal length are perpendicular segments. So they would have needed to show that this was also perpendicular for us to have been able to say yes. Or to have given you some other information. But based on what we're given, we would have had to see that. All right, 16 through 18, they give us a picture. So I'm going to go ahead and draw it. Not that. This is clearly not going to cooperate. This is all given information that I'm drawing on here right now. So 16 says, in the diagram, SV is perpendicular to RT. RT's just supposed to help. There we go. And VR is congruent to VT. Find VT. All right, so we know that SV is perpendicular to RT, and we're told that VR is congruent to VT. It's these little marks tell us. So if they want us to find VT, what would I need? Or what would I say?
It's 8.
Why?
Because it's congruent to VR.
Yep, so VR is equal to 8, so that means that VT also has to be equal to 8. So VT is equal to 8. All right, 18. In the diagram, SV is the perpendicular bisector of RT because UR is equal to UT, which is equal to 14. What can you conclude about point U?
It's on the perpendicular bisector because
Is the UT or VT?
UT. Because what?
using the perpendicular bisector line because its lengths are equal, or UR and UT are equal.
Yep. Since these are equal, and we also know that these two things are equal, then we can say that U also has to be on SV, which is the perpendicular bisector of RT. So U is on SV, which is the perpendicular bisector of RT. All right, 21 through 26 also has a diagram that's shared. They are technically matching questions, but we're just going to talk about solving for them. And then I'll tell you what letter it goes with so that you can see when you're doing your homework. Obviously, you'll only use the letters that are left over. So this one essentially has a giant triangle with cut a bunch of ways. Not really. There we go. And all of these markings that I'm putting on here would have been given to you.
Is that a J or a U?
Right here, it's a U.
Alright.
Just a sideways U, so it does kind of look like a J. There. Oh no. Okay. So that would have been all of your given information. And notice this 3.36 is on this line here. Let me make sure that's right. Yeah. It's on this line here, so just be aware of that. That's not a degree value, but these other two values, the 50 degrees and the 30 degrees, obviously those are angle measures there. All right, so 22, they want us to find the measure of angle XTV. So that's, here we have XTV, so that's this angle over here. So how would I go about finding this angle?
You would subtract 90 and 30 from it and get 60.
Yep. 180 minus 90 minus 30, so 60 degrees. And in case you're just so inclined to want to know, that's letter A of your answer options. Um, 24, VU. So we want to find the measure of VU. Oh, I just realized I forgot a marking. That is also a right angle there.
I just kind of know one question where it said identify all the triangles. That one tripped me out.
Any ideas?
Are they not? The 50 degrees one doesn't count for that, right?
Well, we're trying to find, I mean, it might, but not necessarily. We're trying to find this side length right here.
Oh.
So we don't want anything with degrees. What, Jonathan? Did you say something? He said something.
I'm looking for my options because I'm thinking there's a 1 in 3 chance I get this right, I guess.
All right, your options are 8, 4, or 3.36.
3.4? 3.36.
3.36.
Oh, because it's like congruent to the other one?
Yeah. Because this is a bisector.
Ooh.
Because this angle is, they didn't tell us that, but we know that that's an angle bisector because this angle is congruent to this angle. So that means that this side has to be congruent to this side. So you can't just look at the picture and think, oh, well, it doesn't look like it's the same, because obviously I'm human, first of all. So my picture doesn't look perfect. But even in the book, it doesn't necessarily look like it's perfectly even. Now, that was answer option F, in case you're so inclined to want to know that. 26, the measure of angle WVX. So that's this angle right here.
It's E. It's 50 degrees.
Why?
I don't know. I use process of elimination.
Would it be congruent to the other angle?
Yeah. Yep, it's splitting this there because if this is congruent to this, and this angle is congruent to this angle, we also know then, right, that this angle here has to be a right angle if this is 1. This over here also has to be 1, so if these are the same, then this has to be the same here. So that is option E. Questions on those? We're going to get into our proofs here, and then we'll be done.
Holy grail.
All right, 30. Use the diagram shown. It is given that, you can just sit it right there. GJ is the perpendicular bisector of HK. And we're trying to prove that triangle GHM is congruent to triangle GKM. It's not labeled as such, but I'm trying to draw essentially what looks like an isosceles triangle. There we go. It's not labeled that it necessarily is, but that's what it looks like if you just look at it. All right, so they've already said that GJ is the perpendicular bisector of HK, and we can see that HJ is congruent to JK from the markings given in the diagram. So, set up our proof. What's my first thing?
Given.
Yep, the given. GJ is the perpendicular bisector of HK.
On this point,
Yes,
how come we have to give it in the proof?
because we're doing it so that without seeing the problem, they know what was told to us. So essentially, I should be able to look at just maybe a diagram in your proof and know exactly what you're doing. 'Cause obviously, I kind of need a diagram, or it just is random letters thrown together. All right, so obviously, I can see in here that JH is congruent to JK. I don't really need to rewrite that. That's not really going to help me with what I'm trying to show, right? So, what else do I know to be true, perhaps about GH and GK? Yep. And what else in my diagram do I know also has to be congruent besides these two things that are marked, and then these two sides that y'all just told me are congruent? Yeah, MH and MK. I'm going to get to the GM, whoever said that, in just a second. I want the two things that are for the same reason. So GH is congruent to GK, and MH is congruent to MK. Why? You may not know exactly what it's called, but yep, the perpendicular bisector theorem. Obviously, that's why you have your theorem and postulate book. But for right now, we're just getting used to it. All right, and then somebody said that GM was congruent to GM.
Oh shoot, I forgot to write.
What's the reason for that?
Reflexive.
Yep, reflexive.
She was asking. That's the reason I forgot to write.
All right, now, obviously, I could say that GJ is congruent to GJ. However, I'm trying to show that GHM is congruent to GKM. So I don't need this bottom part of this down here, right? I just need GM for this side length here. So that's why we just did GM instead of GJ. So then I have said that GH is congruent to GK, so I'm going to mark that. Let me do one here. I've said that MH is congruent to MK. And then I just showed that obviously this reflexive side is congruent to itself. So triangle GHM is congruent to triangle GKM by side, side, side. Huh?
A perpendicular bisector theorem.
That's a B.
It's a B. It kind of looks like a B. I think.
There's like a tail right there.
Oh. Wait. How are you blind?
All right, 32 is they filled in part of the proof. We have to fill in part of it. It's a little bit different, and some of it they've actually given you blanks within the statement to fill in, not like that you have to fill in the whole statement. So this is to prove theorem 5.4. So the one that we looked at that was a paragraph proof in the notes was 5.3. So this is 5.4, which is the converse of the angle bisector theorem. So the given is that D is in the interior of angle ABC and is equidistant from ray A or BA and ray BC. Prove that D lies on the angle bisector of angle ABC. And then I have that diagram with it. All right, I'm going to go through and I'm going to write, this is a long one. I'm going to go through and write everything that was given to you, and then I'll put blanks where we need to fill in the stuff. And this is a pretty long one. It's 10 steps.
Geometry and my dad might be the hardest things in my life. That's a C or a E.
No.
Where?
At the bottom of the that's a C.
Right here?
Yes.
C.
Okay.
I'm going to give you a second to get all of that down. If you have it all, go through and kind of look at those first couple of steps and see if you can figure out what needs to go in those blanks while we're giving a minute for everybody to get this stuff copied over. Scroll up so everybody can see.
You scroll up a bit. Oh, me down, sorry. To 2.
You're that far behind me?
Oh.
All right, we're going to start filling it in because we should be pretty much done filling stuff in. All right, so we had our given information obviously up in the problem. We already said that. We're trying to prove that D lies on the angle bisector of angle ABC. We had our picture given to us there. So D is in the interior of angle ABC. What is the reason for that? Given. D is blank from ray BA and ray BC. Yep. And that was also given. So then the next thing, obviously sometimes the ones where you're filling in are a little bit harder, but they tell me it's the definition of equidistant. So what would have to go in spot 3 here? What is equal to what?
BA is equal to BC.
Nope.
AD is
AD is equal to what?
DC.
Yep. AD is equal to CD or DC, whatever. I try to write them in alphabetical order, but obviously I don't always do that. All right, so then the next thing they have DA is perpendicular to blank, and then blank is perpendicular to BC, and it's the definition of the distance from a point to a line. So what goes in this first blank? Yep. And it would get the symbol for array on top of it because that is array going that way. What would go in this second blank? Yep. CD is perpendicular to BC. All right, so then I don't necessarily know where they're going with this, but let's look at this reason and see if two lines are perpendicular, then they form 4 right angles. Now, this is a theorem, but this is how they wrote it, which is why I did it this way. We would normally write the theorem number because you have your theorem and postulate book, or you can write it out. That's fine too. But anyways, so what would have to go here then?
Angle A is equivalent to angle C.
Yeah, well, that's true, but that wouldn't be what the reason for this is. Angle A and angle C are what?
Right angle.
Yep. So yes, that is true, but with the reason that they gave us, I would just need to say that they're right angles.
Is that what the next one will be?
No, because the next reason is the definition of right triangles. So if my next step, the reason is the definition of right triangles, what probably needs to be over here? Something about what?
Right.
Okay, about triangles being right triangles. So what would my two triangles be? Yep. Triangle ABD and triangle CBD are right triangles. So then the next thing says BD is congruent to BD. Well, what allows me to say that?
Reflective property.
Yep, reflexive property. So then I've said that, let me go back up here. BD is congruent to BD. I know that AD is congruent to CD here. So using hypotenuse leg, what has to go here in step 8?
Triangle ABD is congruent. Triangle CBD.
Yep. Triangle. What'd you say? ABD. I'm trying to make sure I put them in the same order I was saying. Is congruent to triangle CBD. Something a lot of you miss, just to talk about hypotenuse leg for a second. Hypotenuse leg can only occur when I have a right triangle, okay? Which means that this side is my hypotenuse here, and then it has to be one of the legs. So either this one or this one, but in this case I have this one. So I have my hypotenuse is congruent, I have one leg is congruent, and I have it's a right angle. So that means that it is a right triangle. Hypotenuse leg only works for right triangles, okay? We had quite a few things missed between the review and the test, I felt like, with that piece of information. So, all right, so then angle ABD is congruent to angle CBD. Yep, by CPCTC. And then BD bisects angle ABC, and point D is on the bisector of angle ABC. What? But we have to have a reason. We can't just say prove.
Perpendicular bisector.
Definition of an angle bisector. Yep. All right, so obviously that one was a lot, but they had given you a lot of information, so hopefully that's helping you to start seeing some of what you need to do. Problems for this section: 9, 11, 13, 17, 19, 20, 21,
God.
23, 25, and
I'm
29.
gonna be up till till 2 o'clock.
Yeah, actually, a lot of there's like one would answer.
Most of them are very quick and easy.
I might need to quit.
It's actually not that long.
And I only gave you one proof, so.
One proof and the rest of it's just like no, yes.
Oh, okay.